Hello my amazing students, this is Mrs. A and I'm trying to get those videos out that I promised you. We are doing 1.6, which is solving linear inequalities, and this one is number 10. So I'll go through and do just some problems as we go through. So on this one, remember we're doing inequalities. We're trying to get the variable on one side, just like we always do. So I usually bring my variable to the left, because I'm going to need it on the left anyway. So I'm going to subtract a 10y and subtract a 10y because I always deal with my variables first. Okay, so that one's going to go away there. And negative 8y, take away a 10y, is going to be a negative 18y. So we have our 12 greater than or equal to, and then a negative 6 over there. So we're getting close. We're going to take away the 12 from both sides because I want to isolate that variable term. And then minus 12 and minus 12. Okay, so that's going to give me down here a negative 18. Y is greater than or equal to a negative 18. Now, what is going to happen when I divide both sides by the negative 18? Remember, when I am dividing or multiplying by a negative number, my inequality sign must flip around. Okay, so I'm out of room here, but let's do divide by negative 18 on both sides, all right? Which means I'm going to get y, and when I flip that sign around, it's going to be less than or equal to, and that divided by negative 18 is a 1. So we should get y is less than or equal to 1. And then we need to put that into our three forms. We're going to put it into our interval form, our set notation, and of course we're going to graph it. So I'm going to get myself a little bit of room here since I've already got all my other boards filled up and ready to teach you. So we're going to make a little bit of space. So now remember, to get to set notation, all we have to do then is just take this one and plug a little line in front of it, right? So we're going to have y less than or equal to 1. And then on the other side of the little line, we're going to put a y such that y is less than or equal to 1. That's all there is to it for set notation. For interval notation, you know, because I'm a little bit dyslexic too, I like to graph before I do my interval notation. So let's graph this first. Here's my number line. Okay, so we have a 1 here and a 0 here, okay? And that's as nitty-gritty as your graph needs to get. That's all I care about. So now we're having y is less than or equal to, so we're going to use a closed ball, right, on the 1 to show that 1 is part of the solution, not just the boundary. And then y is going to go off to the left, and make sure that when you do your graphs, you actually put the line just a little bit above the other line so that I can tell which way you're moving. All right, so now once we've got it graphed, it's very easy to do our interval notation. So we're going to come from negative infinity, okay, negative infinity all the way up to 1, including the 1. So we'll put our bracket there and our paren over here, and this would be our interval notation. And that is the end of number 10. Okay, so now we're going to move on to number 16. And number 16 looks like this. Okay, so we're going to FOIL the left-hand side and get x squared. And an x and a 2x added together is a 3x plus 2, when I multiply, is greater than x squared plus x. Okay, so that's what we have. Now again, we're going to try to get all of our variables on one side. Isn't it nice that our x squareds cancel? So we're going to have an x squared over here and an x squared over there, which cancel. We will subtract our x from both sides. Okay, so now we end up with a 3x, take away an x is a 2x, plus 2 is greater than 0, okay, which when we subtract the 2 from both sides, so we're going to subtract the 2 and subtract the 2, okay? So get a good picture of that because I'm about to erase some of that. So we're going to come up here and use some of this workspace here. Okay, so this is what we have. So we have 2x. Oops, that one is drying out. So we have 2x is going to be greater than, and now the 2 cancel, and then I get a negative 2 over there. So now I'm going to divide by a 2, but since I divided by a positive 2, I do not have to flip my sign around. So I have x is greater than negative 1, all right? So now we need to write that in the 3 forms. So since I already have x is greater than negative 1 here, I'm just going to go ahead and put the set notation by putting a little line, sticking the x in the front, x such that x is greater than negative 1. And then for my graph, here is my 0, here is my negative 1, and I'm going to open circle because I don't have an equal to there. So that means the negative 1 is a boundary. It's not part of the solution set. So we're going to put our negative 1 open circle. We're going to go off to the right. Okay, and so then to get my interval notation, we'll just put that up here. I'm going to follow what my graph says to do. I'm going to go from negative 1 open, so that's going to be parenthesis negative 1 to positive infinity. And there we have it. Okay, so that's the answer to number 16. All right, so here we are back with number 20, and we're talking about domain. These are not inequalities, but these are domain problems. And when we have a function that has a square root in it, we have to remember that if we had a negative underneath the square root, then we would have an imaginary number, not a real number. And when we're talking about domain, we're always talking about where the function exists in the real number system, okay? So we have to make sure that 2x plus 3 is greater than or equal to 0. That's what's going to define this function's domain. So 2x plus 3 greater than or equal to 0. 0 would be okay because we can take the square root of 0. So now we're going to have 2x is greater than or equal to negative 3 when I take the 3 and subtract both sides. And then when I divide by both sides, I get x is going to be greater than or equal to a negative 3 halves. So negative 3 halves. And this would be the domain of the function. X is greater than or equal to negative 3 halves. Okay, that's its domain. So now here's another function down here. This was number 22. And again, we're just trying to determine the domain. And on this one, we have one extra stipulation because we have a square root, which means we can't have a negative underneath it. But then that square root is in the denominator, which means that unlike this one, it cannot be 0. So this one, because it was in the numerator, could be 0, greater than or equal to 0. But since this one is in the denominator, it cannot be a 0. So then to find its domain, we will say x minus 8 minus x is greater than 0, not equal to 0. So then when I subtract the 8 from both sides, I'm going to get negative x is greater than negative 8. But then I don't want negative x, I want positive x. So I'm going to multiply both sides by a negative 1, which means I will have x is less than, because that sign's got to turn around, x is less than 8 would be that domain. Okay, so as we do this one, this is one of my favorites. I really like 3-part inequalities. They're kind of fun. So when I'm doing a 3-part inequality, I'm always trying to get an x right here in the middle. Okay, so I'm going to try to get rid of this 1 because I'm always trying to get my variable term by itself. So I'm going to subtract a 1 and subtract a 1 and subtract a 1 from all 3 parts. Okay, which is going to be a -4 is less than or equal to a 5x is less than or equal to a 2. Okay, so now I'm going to divide all 3 parts by a 5. Divide by a 5 and divide by a 5 on all 3 parts. So now I wind it with -4/5 is less than or equal to an x is less than or equal to a 2/5. Okay, now that is a 3-part inequality. It is also an and. Okay, so this one is saying that x is in between -4/5 and 2/5. So if I was going to graph this, I would have -4/5 over here on the left, okay, and positive 2/5 over here on the right, and I would have a dark circle and a dark circle on both sides. We'll just kind of throw it in there. Okay, and we would have the line going in between. That is an and inequality, okay? What we call a conjunction as opposed to a disjunction. The conjunction is going to run in between, and it's going to include all the points in between the 2 points. And a disjunction, we're going to show you in just a minute. All right, so here we have a disjunction because it has an or here. So now I'm going to basically, when you're thinking about a disjunction, you're thinking that when you're gonna find an endpoint here, you're gonna find an endpoint there, and instead of going in between, your graph is gonna run off in both directions. But now since these are equals here, less than or equal to, then it's going to be something like that. So I don't know exactly what the graph is going to look like, but it should look something like that. Okay, I just got to find out what are these numbers going to be. Okay, so now we're going to go ahead and start solving each little part of our disjunction. So first of all, I've got 5x plus 11 is less than or equal to -4. And I'm going to simplify that. I'm going to subtract an 11 and subtract an 11 to get the 5x by itself. Always getting your variable term alone first, less than or equal to a -15. So now I want to divide by a 5. So I'm going to divide by 5 on both sides, and since it's a positive 5, my inequality sign stays the same. And I wind up with x is less than or equal to a -3. Okay, so there's my inequality right there. Okay, so now I'm going to keep that solution there, and I'm going to go back up here and do this second one and see what it says, what its boundaries are going to be. So we got 5x plus 11 is greater than or equal to 4. So I'm going to subtract the 11 again, and I'm going to wind up with 5x. This cancels, is greater than or equal to a -7. Okay, well that's not going to be very pretty. We're going to have a fraction on this one. We divide by a 5, we divide by a 5, and we get x is greater than or equal to -7/5. Okay, so here was the answer for the second part. So now we're going to get rid of all of this. Okay, and we're going to go back up and write our or our disjunction together. So this was my first answer. So I'm going to have x is less than or equal to -3, or x is greater than or equal to -7/5. So that is my answer, but how do I write that in my set notation, my interval notation, and graph it? Okay, so we'll say, here's my number line. Let's first just graph this thing. And so here is a -3. And our -7/5 is -1 2/5. So we'll say it's about there, -1 2/5. And then here's my 0. Okay? So now we're going to have x is less than or equal to -3, which is going to go darkened circle on the -3, moving to the left. And then x is greater than or equal to -7/5, which is going to be this way. Okay? So here's what we have now. It's moving off in both directions like I showed you. Okay, there's nothing in between here. It's all going to the left and to the right of the two special points that we had. Okay, so now how are we going to write this in our interval and in our set notation? Okay, so it is fine on your set notation to just go x such that x is less than or equal to -3 or x is greater than or equal to -7/5. Okay, that is fine. That's perfect for set notation. For interval notation, we're going to write it like this. Okay, this is going from -infinity to -3. And then this is going to be a bracket. This is going to be a paren. And then union bracket. Okay, so that's going to be a -1 2/5, or we could have said -7/5. Remember, we're allowed to have improper fractions. To positive infinity. And that would be fine. All right, so I'm looking at number 45 in our textbook. Okay, and it says on 45 that Acme movers charge $200 plus $45 per hour. And Leo's movers charge just $65 an hour. Okay, and so the question was a little bit different, but I went ahead and just changed it for what amount of time would the two movers charge the same? So I'm kind of asking, what is the break-even point? What is the point where both of these are equal to each other? So what we would do is we would express each one as a cost equation. So the cost for getting Acme movers to move you is going to be, cost is going to be $200 flat fee plus $45 per hour. So we'll say 45x, letting x be the number of hours that we are actually in the moving process. And then Leo's cost would be C of x would be just 65 times the number of hours, or 65x. Okay, so if we were trying to find where the two would be equal, then we would come up with setting 200 plus 45x equal to 65x. And then we would solve that for where they would be equal to each other. And then we would know which way to go with which movers. So we're going to subtract the 45x from both sides and get 200 is equal to 20x, which divide by 20 and divide by 20 is 10 hours. So when x is 10, when you're going to move for 10 hours, your price will be the exact same. Okay, up until that 10, you're going to pay less with the $65 an hour movers, but after the 10, you'll pay less with the ones that require a down fee, a down payment. Okay? And that concludes our 1.6. I hope this has been instructional for you. And this is Mrs. A, and may God bless your day.